Hi everyone, it's Coach Fred here, and today we're going to be talking about how to write a system of equations from a word problem. Now, you've been solving systems of equations using several different methods, such as graphing, substitution, and elimination. But now it's going to all come together because we're actually going to be able to solve some real life examples with this. Now, we did start to investigate that, what it looked like on a graph and why systems of equations made sense. But we're going to get right down to how are we going to do this? How are we going to write the equation? So first I want to remind you of a few formulas that may come up, may not, but may come up. The perimeter of a rectangle. So we know that a rectangle has 4 sides. You should also know that it has 4 right angles and that opposite sides of that rectangle are equal. So you can actually mark them with these little congruent symbols like that. All right, so we normally would say that the length is the longer side, so I'm going to use a cursive L and W. So if I was trying to find the perimeter means, all the way around, the sides all added up all the way around it, so that would be 2L plus 2W, okay? The area of a rectangle is when we multiply the length times the width. And then I'm not sure if you remember this, but complementary angles. Complementary angles are two angles that add to 90 degrees. So we might need those formulas. I just wanted to remind you of them. All right, so how do you know even in the first place if something's a system of linear equations? Well, if you have an equation that has 2 variables, okay, such as, 2x plus 5y equals 7, well, that's a function, and you can't solve functions. You need an input and an output. So because this function equation has 2 variables, in order to solve it, to get answers for it, you'd actually need another equation. So how do I know I have a system? I end up having 2 equations, maybe something like this, with 2 variables. The second equation could have 1 variable, but I tend to look for 2 equations with 2 variables, then I know it's a system of linear equations. All right, and we can use any one of those methods that we have learned to solve them. So let's take a look. It says write a system of equations, then solve it to find the answer. We're going to start very basic. The sum of 2 numbers is 115. The difference is 21. Find the numbers. Well, we need our variables. We're always going to have to write a let statement to make our variables. And what's unknown here? It says, the question actually says, find the numbers. So that is your unknown. So we're going to let x equal the first number and y equal the second number. Okay? So then we look at each statement to see if we can write an equation based on that. So it says the sum of these 2 numbers, x and y, is 115. So x plus y equals 115. So right there, I see that I have an equation that has 2 variables, so I'm going to need another equation to solve it because there's no other way right now. And their difference is 21. You've got to remember difference means subtract. So if I subtract the 2 numbers, their difference is 21. So now I have a beautiful system of equations. Both of the equations are in standard form. So right now, looking at this would be set up beautifully to use elimination. Why? Well, because I have 1 variable that has the same coefficient and one is positive and one is negative. So by using elimination, also called the addition and subtraction method, we can add the equations together. When we do that, we get x plus x, which is going to give me 2x, y plus negative y. They eliminate, those variables eliminate, and then 115 plus 21 is going to give me 136. All right, so now I take that and I divide by 2. Okay, so I do 136 divided by 2, and I'm going to get that x is 68. Okay, so but you have to find the other variable. So my y, I'm going to take x equals 68. I'm going to substitute it into one of these equations. It doesn't matter which one. So I'm actually going to do the first one because it's addition, and I prefer addition. So I'm going to substitute 68 in for x. Then I'm going to subtract 68 from both sides, and I get 115 minus 68, which gives me 47. Okay, so let's remember then that that's where the two variables, the sum and the difference, would be equal to each other when they are graphed. Okay, if I were to take all my x's and all my y's and I looked for the sum and the difference on a graph, at the point 6847 is where those two values would equal 115 if added and 21 if subtracted. All right, let's look at another type of an example. Another example is when we're given different pieces of information that relate to a final cost or amount. So for example, 4 books and 2 DVDs cost $75. 6 books and 5 DVDs cost $153. Find the cost of a book and a DVD. So again, we need variables and we get it directly from the question asked. So I'm going to let X equal the cost of 1 book, and I'm going to let Y equal the cost of 1 DVD. Now, why is it 1? Well, let's remember that when we're trying to find the costs of things, the cost is equal to the number of items times the price, right? So if I have 5 apples and they're $1 each, it would be $5, their total cost. So everything we want to base on 1 item. Okay, so now we know that 4 books and 2 DVDs cost $74. So 4 times the cost of 1 book plus 2 times the cost of 1 DVD would be equal to $74, the total cost. All right, looking at the second sentence, 6 books. So 6 times the cost of 1 book plus 5 times the cost of 1 DVD would be equal to $153. All right, so we set up this system of equations, and now we have to decide what the best method here would be to solve, the most efficient method. So in looking at this, there's a couple of things that I noticed. There's not one coefficient that has a variable of 1, so I'm likely not going to use substitution. However, it looks like I would need to change both equations in order to use elimination. So I actually looked carefully and I saw that in the first equation, all of the coefficients were even. So I actually decided to simplify the equation because I do always want to try and make them simpler if I can. So if I divide each coefficient by 2, I'm going to end that. I'm going to rewrite it over to the right so it's nice and neat for myself. So that's going to give me 2x plus y equals 74 divided by 2 is 37. All right, now I want to rewrite that second equation right under it because when I use systems, I like them to be right under each other like that. Okay. All right, so now you can see that now I've only got to change one equation. I decided I was going to multiply the top equation because I just, it looked easier to me. And I decided I was going to change the x's. So I was going to make that top x a -6. So I multiplied by -3. Now you could have chosen to make the y's the same but opposite signs by multiplying by -5. Whatever works for you. It's just the way I chose to do it. Now, when I rewrite the equation, I am going to want to write it right below it now so it's neat. So I have -6x minus 3y equals -3 times 37 is -111. Now, you want to be really careful there because you do run the risk sometimes when you multiply a negative to forget to make that number negative. It's just a common mistake, so just pay attention carefully. Okay, so now I'm ready to eliminate, but I'm going to actually do this just to help myself. I'm going to kind of cross this guy out so he doesn't get in my way. Now I'm going to add the equations together. So the 6x's are going to get eliminated. And then I've got 5y minus 3y, which is going to give me 2y. And then 153 minus 111 is going to give me 42. Okay, so then when I divide both sides by 2, I'm going to get 21. Okay, so the cost of 1 DVD is $21. That's a lot, isn't it? All right, but now I've got to find my x's So I'm going to plug it in. And I'm actually going to plug it into that equation because it's a little bit easier. The 2x plus y equals 37. So 2x plus 21. I'm going to plug in 21. I'm going to substitute 21 in for y to give me an easier equation to work with. All right, so now I'm going to subtract 21. So I get 2x equals, 16? And so x equals 8. So the cost of one book is $8. I want to answer the question, and the cost of one DVD is $21. All right, one more example that I'd like us to talk about is the last one, okay? The last one towards the end of the page. Safety rents a truck at a daily rate of $41.95 plus 29 cents per mile. And City Rentals rents the same truck at $38.95 plus 31 cents per mile. For what mileage is the cost the same? So you always want to be on the lookout for questions that are linear in that form y equals mx plus b, where you have a fixed amount and a changing amount. So remember, y equals mx plus b, the rate of change, the changing value is the slope, okay? And the y-intercept is that starting amount. And it should make sense because our introduction and when we investigated systems of equations, this would make sense because this is where they break even, the break-even point. This is where they're going to cost the same. So if I were to graph it, I'd be likely be in quadrant 1, where the miles would be my x and the cost would be my y. And so each line, one might look like that, one might look like that. Where they intersect is going to be where their cost is the same, and it will tell you at what mileage. All right, so let's state our variables. And the question specifically says, for what mileage is the cost the same? So two unknowns. So M, I'm going to let be the number of miles. And C is going to be the cost. All right, so let's see what we've got here. So safety, rent a truck. We're going to have C equals $41.95 plus 0.29 M. 29 cents per mile. There's that per mile, that rate of change for every 1 mile. And that's safety. I'll label it for myself. And then we've got city, rental car or rental truck. So that's going to be C equals 38.95 plus 0.31 M. Now, I wrote these in B plus MX just because it made the most sense to me. Now, when we're doing these types of problems, you might already be able to tell substitution is likely going to be the best method. Why? Because they are both in solved for form. So all I have to do is substitute 38.95 plus 31 in for C. So it's where I set the equations equal to each other, which also makes sense since I'm trying to find the mileage where the cost would be the same. Okay, so there's my substituted equation. All right, so now I'm going to solve for M. So I'm going to probably bring the 29 cents over to the other side. And I can clearly see that that's going to give me 2 cents. And then I'm going to bring the 38.95 over to the other side, which is going to give me $3. And then I'm going to divide $3 by 2 cents. Okay, so 3 divided by 0.02 is going to give me 150. All right, so let's see if we can answer the question. For what mileage is the cost the same? 150 miles. 150 miles. Okay, so these 3 examples that I went over really are just the basics. We're going to be putting this together a lot of different ways in the coming weeks. So we want to make sure that we understand the basics first. So first, read the question carefully. Get your variables from the question being asked. Always state those variables clearly in a let statement form. And then write your equations from the sentences. All right, guys, hopefully that was a helpful introduction to writing a word problem. We're going to be practicing this tomorrow in class. Have a great day.